Alright guys, we're going to get started with section 5.1 today, and we're taking a look at properties of exponents. One of the most important things that we need to remember when working with exponents is that anytime, give me 1 second here to get a pen ready to go, anytime I have a base, so we're going to go ahead and call this A value our base, and I'm going to call this B. So remember, whatever our big number is our base, and whatever power we are raising it to is going to be our exponent. So we want to make sure that we're able to tell the difference between the two. Okay, so we have a total of 7 different properties that we need to take a look at today. And we're going to be able to apply these properties in a little bit more complicated problems as we continue within this section and into the next chapter. So the first property that we're going to take a look at is the product of powers. And by definition, the product of powers says if I have base A raised to the power of m, and I'm multiplying it by base A raised to the power of n, if my bases are the same, and if I'm multiplying, I can go ahead and add my exponents. So I have A raised to the power of m plus n. So if we take a look at example 1, we have 5 to the third times 5 to the fourth. My bases are the same. We're multiplying, so we know we should be able to add our exponents. So 5 raised to the power of 4 plus 3 gives us 5 to the power of 7. In example 2, I have 3. Okay, I have 3 bases. They're all the same, base of 4, with 3 different exponents. So I have 4 raised to the power of 3 plus 5 plus 2. As soon as I add those up, we should have 4 to the power of 10. Okay, I'm going to go ahead and skip column 3, where it says example 3, the ones for you to do on your own. I'm going to skip over those right now, but we'll come back to them at the end. If you feel like filling them in as you go, by all means, please do so. For the second property, we have a power of a power. So if I have base A raised to the power of m, raised again to the power of n, so I have a power raised to another power. This property, by definition, it says that we can go ahead and multiply our exponents. So I have A to the power of m times n. Looking at example 1, I know I can go ahead, I have a power raised to a power, so I can actually rewrite this as 4 to the power of 2 times 4. And of course we can simplify 2 times 4 as 8. Similarly, in example 2, we have a power raised to a power again. I can rewrite this as 7 to the power of 2 times 3. And of course, we get a final answer of 7 to the 6th power. For the third property, we are taking a look at the power of a product. Now, we know anytime we have the word product, we're going to multiply. So I have 2 different bases. I have A times B. And if I have a product raised to a power, this property says that we can basically distribute in that exponent. So I can actually rewrite this as A to the power of m times B to the power of m. Now, you might be thinking, can I simplify this further? But remember, if we're multiplying, our bases need to be the same. It doesn't matter that our exponents are, but if we were trying to simplify this, we'd actually have to stop. So let's take a look at a couple examples with power of a product. I have a product of m times n. So if I want, I can go ahead and distribute that exponent, and I can actually rewrite this as m to the power of 4 times n to the power of 4. And once again, I can't go any further. Now, example 2 is going to be a little bit more tricky because I'm dealing with a number. So I can actually rewrite this as 12 to the power of 2 times x to the power of 2. And of course, we know that 12 to the power of 2 is equal to 144. So my final answer should be 144x squared. Property 4 is taking a look at negative exponents. By definition, I absolutely cannot have a negative exponent. And if I see one, I have to get rid of it. So I'm going to put a star by that. This is something that we need to look for. No negative exponents allowed. So if I'm given a problem, if it looks like A, base A to the power of negative m, I can go ahead and move my base to the denominator. And as soon as I do that, my exponent becomes positive. Now in this case, I do have to make sure my A value is not allowed to be 0. My base cannot be 0, so I just have to watch for that. In example 1, we have 9 raised to the power of -3. So now a little alarm should be going off in your head telling you that this is not allowed. So I know that I can rewrite this as 1 over 9 to the power of 3. And I'm actually going to go ahead and leave my answer as that. Since this number is kind of small, I could rewrite it as 1 over 729. But the bigger these values get, the longer our numbers are going to be, so we're just going to stop there. Likewise, if I have 3 to the power of -4, another alarm should be going off. I can rewrite this as 1 over 3 to the power of 4. Luckily for us, 3 to the power of 4 is manageable, so I can go ahead and simplify this as 1 over 81. Now, for property 5, we're almost getting towards the end, guys. Don't worry. For property 5, we are looking at the 0 exponent. And I really like this one because it's really simple as long as we don't overthink it. The 0 exponent says if we have A raised to 0, so if we have any base raised to the power of 0, it's going to equal 1. As long, again, as our base does not equal 0. Okay, so if I look at example 1, if I have -100 raised to the power of 0, we might try to think about that way too much. Okay, but again, keep it simple. Anything raised to the power of 0 equals 1. Example 2, along the same lines, any number, any base value with an exponent of 0 equals 1. So not only does -100 raised to the power of 0 equal 1, but if we had 7,657 raised to the power of 0, it would also equal 1. All right, guys, we have two more properties to take a look at. Okay, property 6 says if we have a quotient of power. So we know if we see the word quotient, we are looking at a fraction. So if I have a to the power of m over a to the power of n, as long as my bases are the same, like they are in this example, I can go ahead and write this as a to the power of m minus n. So if I'm looking at a quotient, I'm going to wind up subtracting my exponents. So let's take a look at this. In example 1, our bases are the same, so I can simplify this. I can go ahead and say a to the power of 7 minus 3. And of course we know that 7 minus 3 gives us 4. So my final answer will be a to the 4th. Okay, I can go ahead on to example 2. And if you want to work ahead, please feel free to do so. I have another quotient. My bases are the same, so I can rewrite this as 4 to the power of 5 minus 1, which of course gives us 4 to the power of 4. Last property to look at. If I have a power of a quotient, I'm still working with the quotient. I'm going to have two different numbers, and I am raising it to some exponent. In this case, you do notice that our bases are different. I have a and b, so I'm not going to be able to do too much to simplify those. But based on this property, I can go through and distribute that exponent value. Okay? So if we want to see what this looks like, if I take a look at 3 to the power, or 3 over 4 raised to the power of 2, I can rewrite this as 3 squared over 4 squared. And now we can simplify. I know that 3 squared equals 9 and 4 squared equals 16. Likewise, looking at example 2, I can go ahead and distribute that exponent. So I have 1 over 4 over 2 to the power of 4, or I'm sorry, 1 over 4 divided by 2 to the power of 4. Okay, I can go ahead. 1 times 1 times 1 times 1 gives me 1. 2 times 2 times 2 times 2 gives us 16. Okay, guys, I'm going to go ahead. I'm going to encourage you to pause the video right now, and I would like you to try column 3. I'm going to go ahead and work through the problems so you can check your answers. I'm not going to give an explanation for each of those, so make sure that you go back and you check your notes. If it helps at any point to rewind the video, please make sure that you are doing so. So go ahead and try column 3 now. All right, ladies and gentlemen, once again, I'm not going to go through and give explanations for each of the problems, but I do want to make sure that you can see each of the solutions. For number 1, for the product of powers, we should have an answer of m cubed. For number 2, for a power of a power, we should have a final answer of 4 to the power of 30. For number 3, the power of a product, we should have a final answer of 64 times y to the 3rd power. For number 4, if we want to go ahead and leave this in exponential form, that's okay. We should have a final answer of 1 over 2 to the power of 5. For number 5, any number raised to the power of 0 will give us 1. So we need to make sure that that is the only possible answer. For number 6, 3 to the power of 9. And for number 7, we should have 1 over 9 as our final answer. Okay, now you guys have reached the end of our notes for today, for this weekend. The last thing I would like you to do is to go ahead and flip your paper over. You have 6 more practice problems. Okay, so these are going to be maybe slightly different, maybe slightly more complicated than what we just took a look at, but I would like you to go ahead and try your best on these 6 problems. I'm going to be checking them to make sure that they were at least attempted over the weekend, but I will definitely go through them and answer any questions that you have on Monday. So please take your time, do your best, and then we'll see you then. Take care, guys.